What's up, everybody? How are we doing? I was watching the intro with Morty right there. I see we got Shreya here. Mubot is awake. My presentation went well today. We had lots of fun. And now we're going to Kahoot on the practice conceptual. I can't come up with new tabs on my computer. It terminates my Proctorio. Oh, well, we should. Let me double check everything on the current Proctorio. Let me go look at the Proctorio settings for the thing. So once people start taking it, it says record video, record audio, record screen, record web traffic, desk scan is off, force full screen no, only one screen yes, people might have more on the screen, in quiz links only, tabs allowed, there we go. Okay, disable printing, disable clipboard, block downloads, clear cache. Okay, there we go. I think we're good. I am not the biggest fan of Proctorio. I'll just put that out there. I don't want to verify something. We got both. We got the calculator on. Okay, I think we're good. Okay, so it shouldn't do that. Please alert us immediately of any of issues. If we're doing it in person, do we do it on paper? No, you'll still be doing it online. That way everyone does the same. But if you do it in person, you will have access to the instructors who are there, and you can raise your hand and say, "Hi, I have a question. What does this mean?" So if you are doing it in person, you have access to the instructors. I think it might be because it opens in Microsoft Edge. Yes, so let us know. It should work now. I've just checked the settings. But good to see everyone. No, I changed it so you can all have more than one screen because that's going to cause issues for some people. Just please, 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 please. I know this sounds crazy, but make sure you don't do anything that's like related to cheating. Don't do anything possible cheating-wise. No cheating. No cheating. Can we get a no cheating chant in the chat right now? Do not cheat. Because one, it's not fun reviewing through videos looking for cheating. Please don't do it. It's not fun making accusations of cheating. So whatever you do, do not cheat. I'm not about... No, I wish I was. That'd be fun. But do not cheat. We're going to throw some points out there and we'll start the Kahoot here in a moment. So the exam is not on paper. It's Proctorio for everyone. But if you're online, do not cheat. Do not cheat. Do not cheat. Do not cheat. Don't send people stuff. We get messages from students saying, so I'm in this group me and someone like posted like what's on the exam. We're like, oh no, why? I mean, we want you to tell us. But we're like, why? No, like don't. Who did that? And then we gotta... I've already had to deal with that once this year. So can Tiny Brian ask us not to cheat?
Tiny... Wait, that's not my voice.
Tiny Brian says, don't cheat. Don't cheat. What's me about gotta say?
Robots do not like cheating. Cheating is bad. You do not learn from cheating. Do not cheat. Mubot overheats from cheating. Stop cheating. Never cheat. I have to... Whoa.
Coming back there. Evil Brian to see every version of Brian will ask you not to cheat. I have to say this, like in high school in history, maybe didn't learn it well. That was the last time I ever did something I regret. And to group me class chats are pure misery. Hop over to the Discord. Let's hop over to the main screen and we'll start some Kahoot. Hop over to the Discord where we learn and have a great time. Oh, I pressed the wrong button. Adam Spanbauer is an absolute beast. Give shout outs to Adam Spanbauer right now. And thank you everyone who's so positive towards our department. But Adam Spanbauer might even be helping people with SQL. He was like, hey, I know a little bit of SQL. I'll give you some advice. And I'm like, hey, that's Adam Spanbauer. You are the man helping people out. So we can only open the link attached. The links should be working. We'll see if there's... Oh my God, wait. There's icons now? What? Kahoot has icons? When did this happen? Oh my gosh, that's so cool. And they got costumes? We don't use GroupMe, we use Discord and no Zoom YouTube. We're all about it. And now we got Kahoot icons. So one thing I want to point out, Adam Spanbauer is awesome. Thank you so much to Adam Spanbauer for all the great things he does and helps out and posting those tips. Check out the tips if you haven't seen it yet. But also check out what we did today in class. So if you want, we're going to do like conceptual review right now. What's the code? I'll show it again in a second. Check out where we were doing this. The afternoon of the morning class, I kind of did the same things. Went over some questions. Believe me, they're definitely related to what's on the test. And so right here is the code. A lot of conceptual stuff tonight, but do realize you need to be able to solve stuff. There's a lot of solving. Like, I put some stuff in here that you will solve, but then also Brave Rhino right there. I think we definitely today, if you were like tracking with the class, that's really good. Do remember everything before Market Basket is, or everything before, yes, Market Basket is fair game. We're finalizing everything on the exam. Also, make sure, dazzled hair. It is like, oh my God, they really wanted to make sure. Lovely yak. Do you get to pick your thing, like your icons? If you requested a different exam time, make sure that's put in. Remember, if you're online, you don't have to request the time. Also, make sure you have to spin it. Oh, cool. Also, make sure that, whatchamacallit, I was going to say one last thing. You fill out the form. Make sure you filled out the form because that's how I track it. So even if you've emailed me, you need to make sure you have the form filled out. You get 3 spins, but you can't go back. Sturdy zebra right there. If you didn't know, that's what a zebra looks like right there. That is totally... Oh, wait. Why are you sad? Because I'm going to... Wait. He's getting mad. This is so weird. Brave Rhino. Lovely yak. Dazzled hair. It's fun. You can choose accessories. What? Oh, they're totally making it more fun. Amusing camel might be the top right there. Whoa, Sturdy Zebra just turned into a zombie. Sturdy Zebra is getting a crown. What happened, Sturdy Zebra? We'll start here in 30 seconds, so make sure you've joined in. And just a lot of concepts tonight. But remember also, facts right there. Sturdy Zebra, what's up? Make sure you check out class today. Oh my gosh, classy new, you're scaring me. Oh, pumpkin with shades. Make sure you check out class today and be able to solve mathematical questions. What you're doing on the midterm is both conceptual, mathematical, and a lot of the math. Yeah, I did. It's doing all right-ish. Was it class or office hours? Office hours were pretty short today. We did 201. And then I did a presentation on gamification of learning. We did a whole presentation over here on making learning with education and gaming really great. I talked about we don't do punishments in our class. I don't remove those punishments. We don't do that. We do Discord. So they got to hear about the Discord. They got to see some Elden Ring. What's up, Nicole? Then they got to hear about our point system. Then we had, oh, he's going to be the wrong size. Wait, where is he? We'll do this and we'll finish. We'll do the stuff. Mewbot was here.
Mewbot was here. No more overheat. Mewbot took questions. Presentation went great. Woo, wait, gone.
So Mewbot talked during the presentation, talked about how I give points. You've probably seen where you collect, who likes shout outs? I don't think teachers realize, like, would you say on a scale of 1 to like you don't care to 10 you care, like when you come to class online, the teacher's like, hey, Alexander, what's up? Hey, Shreya. Hey, Tyler. Love the levels, right? Because I was trying to tell them, like, shout outs are really big and stickers work. Like, just these things alone, like 10, 12, makes it personal. Good to see you, Josh. Josh's been here from the start. So 10, yeah, it makes it personal. 10 out of 10 says Michael right there. So definitely, I want teachers to know that, like, when you start a class, I told them, like, I see the analytics. I see the analytics that, like, I get a build up at the start. We'll start right for this. But I look at the analytics on it, and sometimes people start to, like, drift into class. So what did I do because the first, 2 to 5 minutes, we're usually just orienting ourselves and talking about just, like, being human. It's just hard to get into your class. Oh, Josh, I think every time we're non-chemist should have a Discord server. Oh yeah. Well, I have an idea to call it the Haslam Discord server. What would you think if that's something I need to have conversations with people about. I don't make those sort of decisions. Brian's not at that pay grade, but I would love it if all of Haslam was on the Discord. So that's an idea. It's an idea right now, but we're not going to do it without 100% support with all classes. So if you were on the Discord server, there's the Teacher Academy coming spring 23. You got to be getting close though. Oh no, we just have business analytics. We'll start here in 30 seconds. Don't create the jokes at all. Channels for different classes, that would be clutch. I know, right? So you just join the Discord and then you'd have any of your classes. T-shirts. So imagine that you join. Here, we'll start here in literally 30 seconds. This is the 30-second timer. We're starting right there. We actually had a Haslam group me. It is great and super helpful. So Discord would be 10 times better. Yeah, we actually already have. So there's a Haslam group me. Is it official or is it just like Haslam group me? Starting here in 15 seconds. So there's is it official or is it just like everyone kind of built it up? Because that's good right there. And then that we were trying to get Discord and GroupMe connected. More just students made it about a year or two ago. Cool. Well, with that, it's Haslam Home. Yeah, cool. With that, you know what time it is. I need some I'm readies in the chat. We got some spooky music, but we don't do spooky music here. Where's my... Oh my gosh, they moved the controls. We're going disco. We always go disco here. Woohoo, we got some I'm readies in the chat. Here we go. 3, 2, 1, let's Kahoot. Woohoo. It's not summer. Updated it. I'm ready. What does Lyft tell us? What does Lyft tell us? What does Lyft tell us? So they moved the thing. It's like they moved it for me. I should disappear though. I might be blocking the right answer. All of these are 30-second answers. Now here's the thing. You do not need to only know what Lyft tells us. And there are some interpretation questions we're working on, so you might have to interpret stuff. But you also need to know it's totally summer right now. You know that. I was updating the summer one. And then forgot to change the title of it. Lift is the factor increase / decrease to probability. What is a lift that we wouldn't care about? What is a lift you don't care about? The lift you would least not care about is what? Like a lift that is like, I don't care. As Rock would say. It doesn't matter. What is a lift we wouldn't care about? 1. 0 you would care about. Because 1 would mean what? The probability what's? 1 would mean what? If we think about, this is examples from class today. So if we think about over here and the lift, 1 would mean what? It stays the same. So this is if people have donuts. We changed it to donuts there. Donuts. So that's 60%. It's going to be hard to make it stay the same. And then, so what would be the lift? Well, if the rule is donuts, peach. So what is the lift of this rule? So what is the lift of the rule? Donuts, peach. So you're only looking at this. How do we calculate lift? You first need to know what, which is going to be some more of the review questions here. What do you need to know? Not quite. Good answers. Elena right there. Let me throw you some points. People are saying the lift is 2/2. Let me double check. Is it 2/5? Well, we'll find out. Let me think. What's the first thing we do when we calculate lift? What do you need to know first? To calculate lift, you probably first need to know what? What should you first know? To calculate lift, you should first know what? Not support. Good answers right there. Not support of rule. Support of peach, which is the original probability. The original probability right there. And Annabelle, great answers right there. 1,000 point. Yes, that's what we're going to use right here. Annabelle's got the formula in the chat. And it looks like James has found the answer. Another 1,000 points from James right there. I believe James has the right answer. So the answer is going to be 1.25. That does look accurate. So it's 1.25, right? Double check the math, everyone. But I think James has it right there. Amazing work, James. And keep up the great work. Keep up the great answers. Because how can you figure out the support of peach? How can you figure out the support of peach? What is the support of peach? And what does that mean? And you'll see these as review questions coming up in a second. What is the support of peach and what does that mean? So you have to look right here. Support of peach is what? Support of peach means 2 out of 5 cards have peach in it. And so that would be 0.4. Then what is the confidence in the rule? So the confidence in the rule looks the following way. The rule is red. The rule is red. Given donuts are in the cart. Don't worry, that's donuts now. Given that donuts are in the cart, what is the probability peach is in the cart? So given that donuts are in the cart, what is the probability peach is in the cart? So what is that right there? What am I showing to you visually? 2 out of 4. Does that make sense? 50%. So now we could, I don't like solving math like that. And then there you go. There's that. So can you, yeah, it's 5/4. I guess you delete those and flip it. Oh, that's interesting. I guess, these cancel and then it flips to 5/4. Huh. I guess if the denominators are the same. Algebra's weird. Algebra's weird. So there we go right there. That is the lift, which means given donuts are in the cart, what? What does that mean? Given donuts are in the cart, someone is what? How does that read? What does that mean? Given donuts are in the cart, someone is what? Or the probability of given donuts are in the cart, the probability of peach being in the cart, they're 1.2, it's a factor increase, so yeah, 1.25 times more likely. Given donuts in the cart, someone is 1.25 times more likely to have peaches. Exactly. Or peach. This was Mario examples earlier. 1.25 more likely to buy peach than they were at random. Exactly. Because this is random probability is 0.4, which is known as the prior probability. So this right here is prior without any knowledge. And then over here, we have the new probability up above, which is the confidence in the rule. So given they have donuts in the cart, which is 4 of them, 50% of the carts with donuts, which is 2/4, right there. So good work, and try to visualize it, try to draw it out. A few more reviews. So there's going to be a review. Who's in the lead? Who's got the fastest fingers right here? It's Dandy Snail. You bet it's Dandy Snail, but glowing dog looking like a Viking over there, looking great. 2 points behind. Next question, get ready. It's going to be quick. The next quick question is, what does support tell us? And this is just support. So what does support tell us? What does support mean? Factor increase to the original probability, raising it by 1.25 times. And so the least significant rule support. Oh my God, lift. Sorry, the least significant lift would be 1, because that means the factor. It's had a factor change of 1, which is no change. So the least important lift is a factor change of 1, and then lift less than 1 means a decrease. A lot of people said the probability of having all items in the rule. So what now that is, I do agree, but whenever I talk about that, I call it what, which you'll see coming up here in a moment, why I put this on here. Whenever I talk about that, that is what. And then we'll go look at our example. That's the support of the rule. So it's good to distinguish when talking about support, like support of an item. So I maybe should have written the support of an item. But when you just say support, it means like probability of having this. So usually we talk about the support of a rule. So what is the support of this rule right here? Euclidean. I'll double check my spelling. Where did I close that out? No, it's an old document. That's why I went to old ones. What is the support of this rule? What is the support of the rule? Donuts, peach. And then how would you know that? What is the support of this rule? What is it, man? It is 2 out of 5. And why is that? Why is it 2 out of 5? The support of the rule means what? And so it's 2 out of 5. That is correct. And why is it 2 out of 5? Why is it 2 out of 5? Because in 2 out of 5 cards, all the items in the rule are contained. So the support of the rule is the percent of time all the items in the rule are contained in the cart. What is the support of donuts? Which I believe is the coverage, which we don't put on the test. We don't need to talk about coverage. The way I memorized is that you support your right-hand man. And the support of donuts is 0.8. Great job right there, Andrew and Lucina. Excellent work. It is 0.8. That is the support of donuts, because 4 out of the 5 carts have it. And we usually talk about that as like support of an item. So very important right there to distinguish. Make sure support of an item, support of a rule. Make sure you are distinguishing between that right there when you're calculating those numbers. Who's in the lead? Leaderboard shakeup. Oh my gosh. And they got sound effects now. Coverage is left-hand side. Do not expect to see coverage on the test, though. We don't include it. And we don't usually talk about left-hand side support. Super question. What is RHS again? Right-hand side. Right-hand side. It's just so in our example right here, the right-hand side of the rule, RHS is the peach. So whatever we see right here, peach is right-hand side and donuts are left-hand side. So left-hand side is before the, given donuts are in the cart. So left-hand side is the given. It's kind of what we're seeing if it changes the probability of the right-hand side. Good questions right there, Tyler. Let's throw 1,000 points in the chat. So, next question. Here we go with that leaderboard shakeup. Dandy Snail still hanging on there. What does support of a rule tell us? So, this is a review question now. What does support of a rule tell us? Review question in the chat. So, when you think about support, it's always related to probabilities. Support is going to be related to those probabilities. So, support of a rule, just like we did a moment ago, this is a complete review question, is going to be the percent of time all those items are contained in the cart. So if you are remembering and practicing, we got a lot of review right here. It's the probability of having all those items in the cart. Are they all blue? The last 3 have been? No, I think it's just random chance. That's just, how it goes right here. I don't think they are all blue. Watch out. Let's see right here. That's a review question. People are getting it right. Makai had done cracked the code. Oh no. How is it? Everyone went up, I think. Everyone went up. So it's all tied up. Get ready. Are they all blue? Let's find out. What does confidence tell us? Someone clicked blue really quickly, I bet. No one clicked blue. How do you interpret confidence? You might have to do some interpretation questions. How do you interpret confidence? What does it mean? Watch me have selected blue. So confidence, think about saying how confident you are. So let's interpret confidence and let's write a sentence with it. Are you ready? Great job. A lot of people got it right there. So it wasn't blue. One person said, I bet it's blue. Let's write one sentence right here using the word confidence. So the confidence is 0.5. So write one sentence and use the word confidence. So I want you to somehow say confidence while interpreting confidence. So think how this rule right here has 50% confidence, and I'll show how that's calculated. So the confidence right here of 50% is calculated by doing the following. And we'll see what people say by using the word confidence. If you have these 4 right here, we see in 2 out of the 4 that the item is contained. So we are 50% confident that peach will be in the cart if donuts in the cart. Yep. Or I start with the given donut. Great job, Whitson, right there. Given donuts is in the cart, we are 50% confident that peach will be in there too. So you can see how it's based on something being in the cart. So it's the amount of confidence we have given one other thing is already in the cart. So that's kind of the key there to remember. Given, great job, Lucina, right there. Given donuts is in the cart, we are 50% confidence there will be a peach. If donuts contain the cart, we are 50% confident peach is contained. And just think about just think about what you're saying and be like, okay, it's confidence. How confident am I that this will be in the cart given the other thing is already in the cart? And that's how we interpret confidence. So excellent work. Make sure to know how to interpret and make sure to know how to calculate these things. Interpret and calculate is the key to success. Well, the given matters. The given is always for the which side. Great job, Dandy Snail. The given is always for the what hand side of the rule. Because you could have a completely different rule. Ooh, this is interesting. What is the confidence in peach donuts? Should be pretty easy to calculate. What is the confidence in peach donut? And I'll show this right here. Remember, because it's only given the first things in the cart, it's 100%. And so when we look at this, given peach is in the cart, so you're only evaluating how many carts right here. So how many carts? Given peach is in the cart, you're only evaluating how many carts? How many carts are you evaluating? 2 carts. So then what percent of the time is donuts in the cart? Given peach is in the cart, what percent of the time is donuts in the cart? And the lift would be 1. The lift would be 1.25, I think. Is the lift 1.25? Someone confirm my answer. I believe the lift is 1.25. It looks to be. It is. James confirms. Great job, James. And if you want to show the math, write the math while I'm showing you it right here. The original probability of donuts is what? The original probability of donuts is 0.8. The new confidence is this, and thus the lift is 1.25. So that's so the original probability of having donuts was 80% of carts had donuts. And now, really? There we go. The original probability, yep, lineup, great job right there, and great job, Alexander. The original probability, it's if you practice these, you get them down really well. The first semester I taught these, and it's your first semester learning right now, I'd reverse things, get it wrong, be like, oh no, oh, it's lift, confidence, support. You just got to repeat them a whole bunch of times. You got to say them 3 times a day. Lift, confidence, support, coverage. Don't worry so much about coverage. Coverage of this would be 40%, but it's left-hand side support, but whatever. Just call it left-hand side support. So that's why I say it's supportive donuts, which is the prior original probability. So the 1.25 here means that there is a factor increase of 1.25 to the probability of buying donuts, given someone has peach in the cart. So great work, good practice. And let me just show the other one again, because someone did ask. I want to make sure we show all questions. Please keep asking those questions. I think someone said for the previous one, why was it, I think they asked 50%, was it the confidence? Why is it 50% confidence? How is this number right here? I'm going to highlight it. How is this number highlighted? How is that confidence there being highlighted? And you can see the math. How is that number being calculated, and what does it mean? That's the confidence right there. So when you do confidence, you would look at these carts. Well, those are the ones that don't out of the 4. Does that make sense right there? 2 out of 4 cards. So the confidence is the percent of time, because Peach isn't exactly Annabelle right there. Great job. And understanding the terminology, just practice, practice, practice. So Annabelle, another 1,000 points. Just keep saying it, keep practicing it. So when you get to the test, it's second nature. And that way it's easy. That's what we try to do right here. How often Peach's bought? Exactly. Oh, so you do out of all the carts that have donuts in them? Got it. Exactly. Because it's given donuts is in the cart. Great job right there. And thank you, Lucina, right there for asking. Given donuts is in the cart, what's the probability that Peach is in the cart? Because that's the way the rule works, is we're looking at the new probability given the prior information. So that's the key. Next question, here we go. Multi-select. How is Euclidean distance calculated? Little tricky of a question right here. Tricky question. Decipher these hieroglyphics. Can we speak? How is Euclidean distance calculated? It can get more complicated than this. It depends on how you want to write it out, but it's a basic formula. Interestingly enough, the 2 answers to this are... Oh God, I can compare on the screen. Right there. A squared plus B squared equals C squared, and A squared equals B squared. This is when you're doing it in 1 dimension, the yellow answer down here, and this is when you're doing it in 2 dimensions. But if you're doing it in a multi-dimension space, it'd be like A squared plus B squared plus C squared equals D squared. So when you look at this, the easiest way to understand it, got to check Euclidean spelling all the time. The easiest way to understand it is if you have 2 points. This is the A squared plus B squared. A squared equals B squared. So A squared equals B squared. If you have a point here at 1, and you have a point here at 5, and we talk about the distance, we have 1, and we look at their distances away from each other. How far are these points away from each other? What is the distance these points are away? How far are those points away? This is the one that you don't even really need to, they're 4. So what's their Euclidean distance? The answer is 4 squared equals 4 squared. So it's just kind of like its distance is its distance, because the shortest distance between 2 points is a what? And that's Euclidean distance. The shortest distance between 2 points is a what? So this is the easy one. It's like, well, they're just that far away. That's how far they are away. This is in 1 dimension, like if you measure 1 characteristic. So now we go to 2 dimensions. I've got some review questions on this, and these are definitely on the test. In the 2-dimensional world, you could have a point where is point A? Tell me the coordinates of point A in the 2-dimensional world. We'll call it point A. Where is the coordinate of point A? 2, 2. Does that make sense? So, and you can draw things out, you can graph them out, but it's at 2, 2. And then where is Where's point B? As best as Brian can draw, where is point B? Oh my God. Point B is where? 5, 6. Can anyone quickly tell me the Euclidean distance here? Can anyone quickly tell me the Euclidean distance? Like, so what are you trying to find? You're trying to find that. Does that make sense? And what is that? Like, visually speaking, what is that? Angel got it right there. It is 5. Alexander, you got it is 5. Because what trick did I play? I did a classic triangle. I did a 3, 4, 5, right? Everything on the test, some of the numbers aren't as pretty. That's always one of my issues. It's like, why not use pretty numbers? I guess you can teach with pretty numbers, and then you have to like show that people can do it with hard numbers. So we need to figure out its difference in this dimension right here, and the difference in this dimension is what? These are the two things we need to figure out. What is its difference in the x dimension? Like, what's that distance? You're wondering how people solved it. I'm going to show you the solve right here. That's 3. So we have 3 down here, and we're going to square that. Now, why do we square things again? Why do we square things? Because sometimes they're positive, sometimes they're negative. So you might say, is it 5 minus 2 or 2 minus 5? Rock says, it doesn't matter. Because you're just squaring it. That way you always have positive differences. So don't, like, just think about it, be like, okay, we square it because we want positive differences. And now we go over here in this dimension, and what is the difference in this dimension right here? What is the difference over here? In that dimension, it's 4. And so what do we learn? Well, we're trying to find what c is. But if we add these up, we will get c squared. So if we take these values right here, 3 squared plus 4 squared, we get c squared. So what is 3 squared plus 4 squared? That is equal to 25. So 25 is what is equal to c squared. So how could we find c if we know c squared equals 25? What could we do to find c? This is a classic 3, 4, 5 triangle. Just square root it. There you go. So square root of that, and there you go. So c equals 5. So that is how we can solve this right here. So you would be solving for c squared if you take the differences in the dimensions and square them. And great job right there. Excellent work. Yep. That's it. Annabelle, great job right there with the code. And just knowing how to do it is key. And like, if you can code it, if you can think through it, 1,000 points right there in the chat. That's the key to understanding it and understanding what Euclidean distance is. There's also Manhattan distance. Can anyone, for 1,000 points, quickly tell me? I don't think we put Manhattan on the test. What is the Manhattan distance right here? You can do it super quick. Like that. You can just look at it and be like, oh, it's this. 7. Boom. Because Manhattan just is the absolute distances in all the dimensions. So it's just 7. It's like you go, it's like this, they call it Manhattan because, you know, like Manhattan with the streets, like Manhattan's a grid, so you have to go absolute distance on it. So yeah, I don't think we put that on the test, but I don't know, it's pretty easy. Like, you know, like, oh, it's just the absolute distance. So you just say, oh, that's 3 away, that's 4 away, it's 7. So that's how far they are away. Just another way to calculate how far points are away. There's so many ways. Next, leaderboard. Soaring Rooster, soaring to the top. Focus Sea Lion. So I like your spooky look right there. You're my number 1. You're not going to make a frowny face. Next question, here we go. Question 615. We are using k-means clustering scheme, and K3 makes sense. What do we do next? What do we do next? Now, I guess there's 2 answers. I mean, I'll probably play some video games, but we're not going to stay at k-means 3 till we do some additional work. There's 2 theoretical answers right here, but probably do this. Unless it's like a tiny data set, then you might say, shrink it. The most logical thing we often do, if we have a good clustering scheme, is add an additional cluster. And great job right there. A lot of people know that. How do you figure out the right amount of clusters to add? What graphic do we use to figure out the right amount of clusters? What graphic do we use to figure out the right amount of clusters? There it is right there from class today. The elbow plot. The elbow plot. The elbow plot tells us the reduction of the within cluster sums of squares as we increase the amount of clusters. And so we generally try to find where it slopes down and hits the elbow. We have a saying right there. Alexander knows some elbow plots in the chat right there. We have bad elbow, good elbow, impossible elbow. Why is this a bad elbow? This one's a decent elbow. You see, you can't see my elbow. That's why I say bad elbow. But that's not the full extent of it. Why is this a bad elbow? Like, theoretically speaking, when you're doing clustering, why is this bad elbow? It just, it doesn't, like, it just tapers off. You're not getting a really good like spot where you're maximizing your decrease of within cluster sums of squares. And so we're just seeing like it just drifts downward and we're not seeing a good point at which to do our clusters. So this right here being the good elbow means you've minimized the within cluster sums of squares to a certain point. Hard to tell where to optimize the minimization of the sums of squares. So when you see a good elbow, it's going to stop. Now, why do we have impossible elbow? Like you really won't get elbow plots like this. Even with the randomness, it's not going to jump back up like this. Like sometimes due to the way it's done via the algorithm, you see little blips, little blip, but it is so tiny. But why can it not do this? Because as you increase the numbers of clusters you're using, you will within cluster sums of squares stands for the within cluster sums of squares, and more clusters will not increase the within cluster sums of squares. So what does it look like visually? If we're talking about the sums of squares, we have a distance right here, and then we take it and we square it to make it positive, and then we would do what with all of these squared distances? So we figure out how far that point is away, probably by Euclidean distance, and then we take all those distances and we would what them up. So we'd add them all up. So which of these, graphic 1 or graphic 2, has a smaller, and we look at the sum of all from with each cluster, which of these has a smaller within cluster sums of squares? Graphic 1 or graphic 2? Graphic 2. It's more tightly clustered around its cluster center, hypothetically being like right there. And this would be k-means 2 because there's 2 clusters being used to talk about the data. So that is what, in great testing right there. Thank you so much. Within cluster sums of squares stands for basically the amount of error going out from the cluster, because the means are used as like a centroid, a central area inside the cluster to say this is where the data is. So we're trying to figure out how many kind of centers of data we have, and it'll be used to make decisions. But what, with there being no answers, we call it what? With there being no answers, there's no answers to your cluster this, you're a frequent buyer, you're a seldom buyer. There's no real answers, because what's a frequent buyer? What's a seldom buyer? What's a new buyer? You bought in the last week, you're a new buyer. Wait, maybe you bought in the last month, you're a new buyer. This type of learning is called what? Interpretation. Oh, drop my pen. Unsupervised. Unsupervised. Oh my gosh, I'm totally losing my pen. It's falling under the computer. No worries. I dropped my pen. Unsupervised learning. Unsupervised learning, that's when there's no real answer to it. Data gonna do what data does. That's what we say here all the time. Data, there's no answer. There's no R squared. There's no optimizing. There's no getting it right. There's just trying to get it right. And if we get it right, we do. And if we don't, we don't. And we'll never know. We'll never know. We'll just see our money. If we get more money, that's good. Dandy Snail. Dandy job right there. Soaring Rooster. You're going to soar back into the lead, but Glowing Dog. We like glowing dogs. You sound awesome. Next question. The goal awards distances to what? I'm hoping I selected the right answer on this, because I thought I put this later. I'm going to be really sad if I put the wrong answer here, because I thought this came later. The goal awards distances to what? No, I think it's fine. Let's find out. I'm scared. Brian's scared. Oh, good job. A lot of people didn't get that. That's all right. So merge clusters keeping the smallest distance is what? This is the right answer. Merge clusters keeping the smallest distance is known as what? Like when you merge clusters and then you always calculate the distances based on smallest, that's what? So when you merge, that's simple. Merging clusters, when you keep the largest distance, is known as complete. And then average is average. I guess I did put the right answer. Everything's a blur. So it basically uses the within cluster sums of squares, and that's the distance on the left side of the dendrogram. We talked a lot about dendrograms during class today. Everyone should have access to the class links. So check out where we did some dendrograms, and we talked about how things merge, and check that out right here. What's the story of this dendrogram when you look at it? What's the story? And I'm showing you the points below, but tell me the start of the story of the dendrogram. And if you change the way you do it versus single or complete, you get different dendrograms. What is the story of the dendrogram over here, which we trace through? And check out today's class if you want to walk through and draw a dendrogram. 1 and 2 merge first. So 1 and 2 are the first to merge, and you can see it over here because they have the shortest distance. But then 1, 2's distance from 3, 4 is going to be calculated how? Like how far is 1, 2 going to be away from 3, 4? 1, 2's distance from 3, 4 is going to be calculated how? Because first, 1's distance from 3 is its distance. 1's distance from 4 is its distance. But when 1, 2 merge, the complete distance will be what? 1, 2's complete distance is probably 2, 4. At this point, why is 1, 2's distance? Great job right there, Tyler. It might be 1, 4 or 2, 4. It's hard to say. It's definitely not 2, 3. We can make it a little more obvious right here and make it 1, 4 by doing this. So now it's definitely 1, 4. And why is it that the distance right here after this merge, that the distance between these two clusters is 1, 4? Like that's how far they are away. So why is it that? And I'm talking for this right here. Why is it that? That is definitely the distance. And it's complete. And what does that mean? The furthest points between the two clusters. So when 3, 4 merge, I guess we should say when 3, 4 merge, because complete always goes for the longest. So you have to be careful though, because whenever we merge, we always merge on the shortest distance. This is just how we're calculating the distances between the clusters. So you would merge on the smaller distances, like 5 and 6 are going to merge over there. But remember, we only are calculating the distances via these methods. Because how close are you to somebody? Well, think about this. Are you closer to people in, let's say, Kentucky or Virginia? Well, here's the thing. How far away is Virginia coast? This is the way to think about it. Let me pull up a US map because this you'll see this. I think this works for Tennessee. Let's pull up USA map. So if I ask you, are you closer to people in Kentucky or Virginia? Let's take a look. Kentucky, you think? So think about this. You are right. Oh my gosh, please stop moving around. Oh, really? Oh, let me try to take a picture of it. Oh, no. Let me take a screenshot and we'll zoom in on this. Depends on how you calculate it, I think. Because using which distance, you're probably closer to people in Kentucky. Using which distance, you're probably closer to people in Kentucky. Can you explain why it is? Yeah, Elaine, I'll go back to that. Using single linkage. Let me see here. Knoxville's located right here. You might be closer to Kentucky any which ways. Because your single linkage is the linkage of you to the closest person in Kentucky. There's your single. Oh, that's North Carolina. I don't know I lived in North Carolina. I know my states. I know Bristol over here, the Tri-City area. So I would say you are closer to people in Kentucky. And frankly, you're probably closer via complete. Yeah, I think so. Because your complete is going to be what? I guess if we think of just you or people all in Tennessee. Oh, definitely. If we do all of Tennessee, it's going to be higher. I'll just put it over here. So the complete linkage is the two furthest people. Good elbow right there. The complete linkage is the two furthest people. But if we talk about people in the states, it looks like Kentucky's a lot closer. But does that make sense? This is just a different example right here. If we talk about people, are you closer to people in Mississippi? Well, the single linkage to you, we're just talking about you, would be to here in Mississippi. But your complete linkage would be you to the furthest person. And let's see right here. So maybe a state like Ohio, you might have a shorter complete distance. It looks like shorter complete, but a little bigger single linkage. Maybe. But does that make sense how we do the plots right there and think through them? How are people following this example right here and talking about single versus complete and how we calculate the distance? Like single, which is in green right there, is the shortest distance between clusters, and complete is the largest. So when we talk about states and who's closest, it might be neat to do that for a graph or something, like talk about which states are closest to each other and merge them via single or complete of the population. So that's how it's like, which state are you closest to? What are we talking about? I mean, you think about Texas. Texas is going to be very close to a lot of states, but Texas could be very far from a lot of states. Why? Why would Texas be very close to a lot of states, but also be very far? Because if you think, how far is Texas from Oklahoma? You might say Texas is that far from Oklahoma. But if you do single, I mean, you can just say like it's right next to it. So you might have to calculate distances. Big state right there, yeah. So Texas can be really far away. So everything's bigger. Yeah, Texas is huge. Where are we at? We're down there. That's about where we're at. I think so. I've been literally, last thing right here, then we do more questions. I've literally been probably all across that of Texas. Nacogdoches, Lufkin, Paris. What's the place all the way at the bottom where Corpus Christi? I think Corpus Christi, right? That's all the way at the bottom. I've been all across East Texas from north to south. Texas is a good state. I like it. It's got a lot of good food. Need to eat more good food. So checking out, but I like Tennessee better. You know I'm a big Tennessee fan. The Aggies went down because of App State. You've ever been to? I don't think I've been to the Alamo. Don't think I've been there. Need to check it out. Next question. Focus C line is focused on winning. Here we go with the next question. What is the Euclidean distance between 2-2 and 3-3? It's super cool. Cool. Two and 3-3. Austin and Houston. Want to check out Austin before we leave? I've been to Houston. Never been to Austin. I know they say keep Austin weird. Been to Houston. Never Austin though. So what's the answer of this question? It's not 2. It's what? I rounded it. I did it off my head too. Should throw in the calc. Ooh. What's the answer to this question? It's not 1. I don't think it's 1. Tell me if I'm wrong. It's not 2. So how do you find the Euclidean distance? Yeah, 1.4. What is it? 1.4 something? 1.41 people in the chat. Square root of 2. Square root of 2. Because what is the formula right here? What is the formula? Repeat the formula again to find Euclidean distance right here. It's there. Yep, Alexander's got the full thing right there. Solving it right there. Just finding the distance. You say how far is it away in dimension 1? So dimension 1 is 2 and 3. It's 1 away. Dimension 2 is 2 and 3. It's 1 away. 1 squared plus 1 squared equals c squared. Square root of 2 is 1.41. So that's how we do it right there. Good practice. Check out the earlier one where we solved more examples of this. Make sure to know how to solve things like this. Very important. So speaking of, get ready for another one. Focus C line is focused on that win. Here we go again. Next one, maybe you've already seen it. What is the Euclidean distance between 2-2 and 5-6? Remember, I like a lot of reviews, so you might know it pretty quickly. So the first thing you want to do right here is find the distance between 2 and 5. The distance between 2 and 5 is 3. That's its distance in the x1 dimension. We oftentimes call these the x's. So we have x1 dimension and x2 dimension. We have 2 and 6 has a distance of 4. Distance of 3, distance of 4. Square both distances. 9 and 16. 9 plus 16 is 25. That is c squared. So we don't want c squared. We want c. The distance is 5. Wow. So why was that? How did I'm glad everyone got it right. But how were you able to get that? How were you able to be like? How were you able to get that? How are you able to be like? Or you solved it, which is awesome too. I like a lot of review questions. 3, 4, 5 triangle, right? And so we also reviewed it earlier, but remember how to solve this because it was pretty numbers. We love pretty numbers. Just make sure to solve them and check your work. Make sure it makes sense. The full hypotenuse is going to be bigger than the smaller triangle itself because it'll always make a right triangle because you're going all the way on one dimension, all the way on another. So the hypotenuse has to be longer than the sides of the triangle because it has to reach, it has to go across. So yeah, good one right there. Awesome. Love it. And so, yeah, next question, let's do it. But let's see who's in the lead. Oh my gosh, we got member. And please email me afterwards. Let me know if you won first and second $20 Amazon or Starbucks gift cards. Just say, hey, Brian, I want a Starbucks. Hey, Brian, I want Amazon. And I'll make sure to send it to you. Just make sure to email me. And if you have a preferred email address, let me know that too. Just sometimes people forget to email me or they don't tell me the email address or they're like, oh, wait, send it over here. And just tell me which one. Going on, next question. Here we do it. How do we evaluate the amount of clusters to use in k-means? All of these right here are graphical displays, and it's important to know all of them. Review. Scatter plots are bivariate displays of quantitative variables. So we have 2 quantitative variables in a scatter plot. Histograms are a univariate display of quantitative variables. A dendrogram is a agglomerative method of showing us hierarchical clustering, meaning it brings things together. That's what agglomerate means. Oh, we still do Kahoot and 201 all the time, but an elbow plot is the way we evaluate the number of clusters. What's our saying right here? Not, was it like sleepy cat? I always think that when I say our saying. What's our saying right here? What's our saying? Not like I'm like, yay, woo. So what's our saying? Bad elbow, good elbow, impossible elbow. So hopefully you see things like this where the elbow is telling you, and the graph itself is showing you the decrease in watt as you increase clusters. The graph itself is showing you the decrease in watt as you decrease clusters. The graph itself is showing you the so that's the clusters on the bottom, the K, the clusters, and K is just a placeholder for amount of clusters. Like if we did K nearest neighbors, it'd be the amount of neighbors someone has. So the within cluster sums of squares is decreasing. So once again, I ask this every time because you have to know why we do these things. Why not just, if we have 100 points, do 100 clusters? I don't think I wish there was a theoretical test question. You have to think, why am I doing this? So I want to decrease the within cluster sums of squares. Okay. Well, even though I get a good reduction at, let's say, 2. So this right here would be 2 is a great reduction. It would probably decrease the error. It'll always decrease the error. So it's not meaningful. It doesn't really help us because remember, we're trying to put people into groups like new customers, frequent buyers. And if you're like, okay, I have 100 customers and I've got 100 groups, and it's like, well, then you're just personalizing emails, like to like not even like have marketing strategies. You're just like, which is good. I guess with 100 customers, you might do that if you're growing. But then when you get to 100,000, you're going to make 100,000 like have no strategies that are based on some sort of group that you come up with that's unsupervised. You're just going to look at everyone as individuals for 100,000. I mean, maybe your top customers, maybe, but you're gonna, man, you got a lot of time right there. So we think of clustering as a way to come up with central themes, and the central themes is completely arbitrary. The initial clusters wouldn't have probably, ooh, Hunter, we got to throw some Hunter, some 5,000 points. That is like, if you are in a meeting, Brian's just going on and on. Brian's like, blah, 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 and then Hunter's like, the additional clusters wouldn't provide any additional information. The bosses are like, thank you, Hunter. You're great at communicating. So Hunter, 5,000 points, great answer right there. That's exactly what we should say. It's like, it's really not helping us out. Yeah, just keep with the 2. So great work. That's a good elbow right there. Look where the elbow declines, and keep up those great answers in the chat. We like it. I like it when people are practicing and repeating answers. Great job. So here we go. Next question. Let's do it. Amusing Camel going for the lead, but Focused Lion is focused and already in the 7,000 points. Here we go with the next one. Which of the following uses the largest distance between 2 clusters to calculate distances? Largest distances. Largest. Good review right here. Good review. So wards is the within cluster sums of squares. It's going to look at the reduction by merging things together, and it's going to try to make sure we get the lowest within cluster sums of squares as things merge. Single is going to merge on the smallest, or it's going to calculate via the smallest distance, excuse me. And average is average. We never do that one by hand, nor do we do wards by hand. Complete. So let's try to do one of these. You ready? Let's write one out. Let's write it out. Let's write it out. Draw it out. I like that new effect. I might speed it up a tiny bit, but I do like it. So we have right here the end of a merging, to where we have cluster AB has already merged, cluster CD has already merged, and here is point E by itself. Does that make sense? Like what you would see right here visually, if you have A, B, C, E right there, is something like A would be here, B would be here, C would be here, D would be here, and E is all by itself. How does this sound? So we would have had A, B merge, C, D merge, and now we're trying to calculate the distances between this, which, there we go right there. How are those pink lines being calculated right there? Ooh. Well, we forgot one. All that said. How are those pink lines being calculated right there? What is the way the calculation method is being done? Single. What is the final missing distance that Brian has not calculated here as I start to write everything? What is the final missing one? It might be AC. It's the AB cluster with the CD cluster, right? So it might be AC. It might be if AC or what. Since we're doing single, It would be AC if what? It will be AC if what? If theoretically what, that is the correct distance to be using right here. If that is the shortest distance between the two clusters. So let's say AB has a difference from CD. We want to go right here. I wrote this all crazily like, because AB is going to have no distance from AB. I think we need to put these in ascending order. E, CD, AB. And now this is nothing. That's nothing there. That's nothing there. Why am I doing this right here? Why am I doing this? Why that? Why that? What does that mean when I write this matrix out? What does that mean? What's the point of that? Probably would have worked either which way. What does that mean? So connect the dots. What does that mean? Why does it have a dash for EE? Because that is the calculation of the distance that you can't. Great job, Amanda. 1,000 points right there. You can't have distance from yourself. That is the calculation of E's distance from E or CD's distance from CD. So they've already merged or they're already a point. You can't have distance from yourself, so we don't do calculations there. AB's distance from E is going to be the shortest, so let's go with 4. CD's, and that's what I'm telling you that this distance is 4 right here. CDDE is going to be... My brain just jumps. There it is right there. That's going to be 7, and this one will be 5. So where would we merge? What's going to happen? You can see it visually also. What's going to happen right here? What will happen as these merge? Great job, Ella, also. And what will happen? AB with E, correct. This is on single. AB with E will merge right here. But let's change it. Let's change it right here. Now, let's change the way this is done with complete. So we already have these merged. Okay, these have already merged. And let's do complete. So with complete, how is AB's distance from E calculated? How did you get first 4? Oh, I came up. Are you talking about the distances? I came up with those. Let me rewind time a little bit. Which values are you wondering about? I just came up with the distances right there to create a distance matrix. So if you're wondering how I got these values, I came up with those values to hypothetically ask you what would merge right here. It'd be AB with E merging because we're merging on single, and the distance from BE is the shortest. AB cluster has the shortest distance to E based on B. So does that answer your question, Josh, right there? So those numbers I came up with right there are just kind of looking at it and guesstimating it. Like you wouldn't do it that way, but the computer's going to do it for you. So the computer will tell you. Oh, wait. No, I was going to rewind time the wrong way. Okay, so now the other way we can do by hand to calculate distances or merge is going to be based on complete. And let's take a look. We already have AB merged and CD merged and E. What is going to be the distance AB is from E? How is AB's distance from E calculated? I don't know if anyone said it yet. And oh, they are saying it. Angel's saying it and Morgan's saying it. Great job, Angel and Morgan. We'll throw you some points in the chat. AB's distance from E is A to E. Why? And Makai's got right there too. So we're doing complete right now. We've switched to a different method. Why is that it? And then C. Ooh, nice job. C to E. That's got it right there. And then maybe B to C. These are all the what is distance between clusters. These are all the largest distances between clusters. So every distance right here we're looking at is the largest distance. So now, if this is 6, and this is 7, this is 9, we're doing complete. So CDD is 9, and ABE is 6, and ABCD is 7. Which one of these do we merge on? This is complete. What merges? That is correct. And why? We'll still merge. That is correct. And why? We always do what? We always do what? You always merge on this. This is just how we calculate this. So when you change from single to complete, you're just calculating the distances differently, like how far away are these things. So this is just the numeric values of differences. You're still going to merge the things that are closest, but how close are they? Well, that's going to be dependent on if you're doing single versus complete. So the complete linkage right here is going to be the furthest 2 points in clusters. So we are still merging on this right here because it's still the smallest distance. Anytime you make a distance matrix, you do what? Repeat it to me. There's a question coming up on the Kahoot. Get ready for some multi-answers. Big tip right there for the end of the Kahoot. But anytime you merge on distances, you always merge on the what? Anytime. The way you calculate it is going to be different. But anytime you're doing distances, you always merge on the smallest. Like every time. Anytime you're doing it, you always merge on the smallest. So that is a good example right there. Definitely understand how to do things like this. I drop a lot of hints for the test, just putting it out there. Great job, everybody. We got a few more questions here to go, and then we're going to eat some dinner. We got here Focus Sea Lion destroying it. Great job on fire. Next question. Which of the following uses the smallest distance between two clusters to calculate distances? Just kind of a review. You saw it a second ago. Make sure to know how to do it. Just not only know the name of it, but remember to use the shortest distances. So you'd look at the points in the clusters and figure out the shortest distances. Try examples like that. We did examples during class too, so check out those examples from class. Lots of questions similar to what you'll do on the exam. Wards uses the within cluster sum of squares. Complete uses the longest distance. Average is the average. We don't do that one by hand, nor do we do wards. Single is going to be the smallest distance. Good job right there. Focus Sea Lion can't stop. They won't stop with that 500-point lead. I love finding out who wins these things because that's a good lead right there. Continuing on, get ready for the next few questions. We're probably going to go a little quick because we've done a lot of review. Here we are. Which of the following uses sums of squares within clusters to calculate distances? Just a review, kind of make sure you have it. Been repeating these a lot, just knowing these terminologies, knowing which is which, very important. So a lot of people should be getting these, hence why I've done more examples, because you can only do so much with a Kahoot. The questions are a little bit quicker, so check out where I was doing the calculations, calculating support, lift, confidence, all those things for rules. Check out where I was calculating distances. Also, I was calculating what would merge. Things like that are very important. So if you're looking for examples of things to know, so I thought everyone would get its wards. Great job right there. Wards uses the within cluster sum of squares. Average uses the average distances. Single uses the closest points between clusters. And complete uses the two farthest points between clusters. So make sure you're doing the examples I'm doing and try. Has anyone tried to do what I've done right here and draw out an example? Can you draw out, try drawing things like this and being like, okay, the distance is this, the distance is this is what the distance matrix would look like. And then if you can, show it to a friend or post it on the Discord, but try drawing these things out. Try, figuring out Euclidean distances, see if you can calculate them by hand, and then you understand the formula. Because it's not, people say, why do we need to know a squared plus b squared equals c squared? Well, that's how far are points away. Should we just know what average is? We're not, I'm 99.99% certain there's no calculation of averages because you would literally have to get each point and algorithmically, if you had 2 points in this cluster and 5 points in this cluster, how many calculations would you have to do to find average distances? It's a decent test question too, but I don't think we wrote anything like that. If you had 2 points in this cluster and 5 in this, how many calculations would have to be done to find average distance? So I think you have this point here, and it's going to go through and do the distances between those. And you have this point right here, and it's going to go through and do the distances, and then you find the average of how many distances. It'd be 10, yep. Because there's 2 points here, which are going to have, this one point is going to have 5 distances, this another point's going to have 5. So then you'd find the average distance from the 10. Does that make sense how average works, just kind of theoretically speaking? So you have 2 points in a cluster, or you could say 3 points in a cluster, 5 points in a cluster. What's the average distance? You'd find the distance each point is away from each point respectively, and then find the average of the 15-point distances. I don't think you have to make any. You do have to know how to solve a little bit with them. So the things I'm doing tonight, need to know how to solve it a little bit. Yeah, so we wouldn't make you calculate 10 or 15 distances. It's usually do you know how to calculate a distance? Do you know what single and complete is? And theoretically, what is wards and what is average right there? Good things to know. So I do focus on how would we do it on the test. So definitely know how to solve the questions I can solve and know to write them too. 2 more questions. Woo! Here we go. Here we go. Next question. What's up, Charlie? Good to see you here. What is the log 10 of 100,000? Did Brian select the right answer? He's always fearful. Charlie, do you want to drop it in the chat? So good to see you. We're dropping another 5,000 points for a random Charlie appearing. Charlie, you doing well? I think it's... Give everyone some shout-outs, Charlie, if you want. Everyone got it right there. What's the quickest way to do log 10, and why do we do log 10s? When you do log 10s, what can you do? Force anyone is tough. Yeah, it's statistical methods, right? But everything you're learning right here will help out with those classes. So, like, Charlie has your knowledge from like 471 or 474, 320, has it helped out with a lot of your classes right here? Has it helped out? I hope it has, because taking next semester, yeah, and I'm really hoping we can have some good, strong Discord help. So if you're on the Discord, this semester 474 is where it's at. Let me tell you, I just want to give a huge thank you to everyone who's made the 474 Discord do you feel like who's in the 474 Discord and who's in the 474 Discord and it feels like they can go on there and ask questions? I see some more questions. I'll answer them after because I think they came up right when we were starting the Kahoot. But there we go. Hunter's asking, is Hunter here? Hunter, are you in the chat? I hope Hunter's here. I just saw that. But always feel like you can go onto the Discord, ask us questions, and really great stuff. Shout out to Charlie, man. Keep it up. But post things on the Kahoot. Got a lot of great people, and we're just continuing to grow it. Answers come fast on the Discord, exactly. You got a question, you're stuck on something, let us know. Earlier you start, the better. Hunter! We're throwing Hunter 1,000 points. No, Hunter, we'll throw you 5,000. We're just going a little crazy tonight. Thank you, Hunter. Sorry I didn't reply to that. I was getting everything ready for the Kahoot, and I didn't see the question. So glad you're here, Hunter. We're glad. We hope you enjoy the show. But it's time for the last question, so let's do this. Here we go. It's good to have you with us. Oh my gosh, what even happened right there? Even if it's just for a while. Focus Sea Line, what happened? They are just trying to make it interesting. With Soaring Rooster, Focus Sea Line, and Amusing Camel with the last question. And let me just tell you, it's a crazy one that you should know. Get ready. Here we go. It's a multi-select. Here it is. The last question.
Oh my gosh, last question. Tiny Brian here. Do you know which of the following merge on the shortest distances? How do we merge on the shortest distances? Now this is how we merge. Tiny Brian is here to announce the final of the Kahoot. Tiny Brian even appeared during the lecture today, during his presentation. We always merge on the shortest distance. The answer is all of them. Thank you, Chase. Chase, we'll throw you some points right there. Oh my god, crazy points. If you stay till the end, you get 5,000 points. It's time to announce those winners. Focus Camel, where you at? In third place, it is Focus Sea Line. Whoa, great job. Oh, that's cool right there. I like that. That's funny. Amusing Camel, $20. Make sure to email Brian, not Tiny Brian. But number one is Soaring Rooster. I like what they did with that. That's pretty cool. Soaring Rooster, great job. Amazing job. Let's go with those points. Woo! Tiny Brian, away!
Excellent work, everybody. Glad people had fun. Got a brain with pancakes. What does the world come to? That's when you know. That's when you know things are crazy right there. A brain with pancakes. I applaud you if you spun into that. I applaud you. I don't think there's yet a crazier one. I do like the skeleton with the hat. Amusing Camel, I like that one. I don't know. Those are a little bit crazy right there. Pretty fun, pretty crazy. Tiny Brian is awesome. Thank you so much. We'll head over to the main screen, then we'll end off. Got to eat some dinner here coming up. Brian's like, what does the world come to? Brains with pancakes is what it's come to. Apparently. You're welcome, Shreya. Make sure to email me. Make sure to be writing your notes sheet. Put examples on there. We do have the notes posted that you can have open. Please let us know if there's any problems. It's going to be a busy night tomorrow night. Busy night. It looks to be somewhere between 20 to 50. We're still finalizing it. So I'm trying to make sure everything I did is, like, as we said, it's everything up to market basket is fair play for the exam. And been trying to watch and making sure everything is finalized and good to go. So thank you, everyone, for being here. 20 to 50. I know that's a huge range, and that's my best. I am 95% confident. So what is Brian's best guess? Is the exam multiple choice? There's multiple choice, and we're looking to add interpretations. Let me look at that email again, because I think I kind of hinted at some stuff. Let me go look at that email. Going to look at the emails. Okay, here it is. Yeah. Okay, I think that's, yeah. Put it this way. I'm not going to tell you what we're talking about adding for interpretation on there. Exactly. Yeah, when you're 95% confident, you got to give a wide range. Like, I don't want to be 95% confident. It's between like 34 to 36. So my best guess is around 35. But put it this way, the interpretation that is talked about being added onto it, or that we are likely to have, what would you guess you would be interpreting? Like, if there were 2 interpretation questions, so I'm not telling you what's on there. I mean, but if you had to guess, where would the interpretations come from? People are saying maybe lift, maybe what else? Market basket, so maybe some interpretation of market basket, maybe confidence. Have we practiced writing? And this is prior. Someone can't be like, Brian, you taught this. I didn't even know what's on the test till like yesterday or today. Well, I mean, I know what's going to be on it. But I teach you how to interpret lift, how to interpret a confidence, how to interpret support, how to interpret supportive rule. All those things right there we've been doing repeatedly. And then what else could be another area where you'd have to know how to interpret things? What else would be another area where you'd have to know like a broad topic of where you'd have to know how to interpret stuff? Where would be another area? Clustering with k-means, with dendrograms, with elbow plots, things like that. So knowing how to because we're not just here to write code. We're not just here to get data or to output data. We're here to interpret and give data context. So with that, it is time, everyone. We'll be back tomorrow, 201 class. Busy times. Make sure to email me if you won. So more other topics than clustering. Just generally, sometimes we put some coding questions on there, nothing too crazy. But the current format of it doesn't really have any coding questions, but I don't think I'm going to see any major shakeups to what's on there. I don't think so. It's mainly meant, what we've done in the past and what I currently see, it's mainly meant to look at your knowledge of clustering and market basket. I tried opening the files in the exam and it would log me out. Is there any way to open the PDFs? I made sure the settings on the full exam have it. Once someone's done the practice exam, it must have imported with the wrong things. And thank you for those who said that. The exam itself should allow you to open everything. And I checked the settings on the actual exam. But once the practice exam, you know what I probably need to do? Let me go do this right now. Stay tuned. We're going to do this right now. Let me go get the practice. Give me a second. You're talking about the conceptual midterm preparation. Do not open this. Well, I can. Okay, where we go? Where's duplicate? I will do this while we're doing this, and we'll double check. Okay. Should be able to duplicate it now. Where's the duplicate? Copy. BAS 474. Fall 2022. Got it. And introduction. Okay, at top. Okay, cool. Okay. Let me go see if it's there. 2 seconds. It's copying. Okay. Unpublish. Go away. As soon as I take it right as I have it copied. End notes. Okay. Settings, custom. What should allow it? Is this the old version? I think it should allow it now. It should allow it. Try and explain what a for loop was trying to do was difficult. Yeah, that can be that can be pretty challenging. So it should, Andrew, let me know if you're having issues with it. The test should work, and I'm trying to think. I wish we could have someone it should work. I've got everything set right in the actual test, but you can't oh, thanks, Charlie. It's actually, I think it's 1.5. It's really great. So thank you. We've been going up. We got the 1 million views like a year ago. Yeah, 1.5 million, I think. Or is that what it says when you? We'll end that. We'll end on that note. Got 12, 14 people watching. Here we go. Yeah, it says 1.3. So here's the weird thing. You see, it says 1.3 right here. So that says 1.3. Stat to a 1, P. Stevens. 1.3. And we've been on YouTube for, this is year number 9 coming up. And so almost a decade. If you go to YouTube Studio right here, and then you go to the content, not the content, the analytics, and then you go to, so it said 1.3, right? If you go to lifetime views, that says 1.5. Isn't that so weird? So I don't know, 1.3, 1.4, 1.5, I don't know. But what's really great is if you look at like the views, we've got 35,000 views on that, on tutorials on how to take a random sample. But if you go to like the more recent stuff, like the last 90 days, like the, just right here, exam 1 review contest for 201, 2,000 views. The careers and analytics panel, which we're setting up another one, 1,000 views. In office hours from last month, 1,000 views. In office hours from just last week, 1,000 views. Yeah, I don't know. It's weird, right? Yeah, definitely. So you will, if you're in person, make sure you're taking in person. Do you know how many points in total are allotted for the multiple choice? I do not know. I'd say it's almost 50% from what I've been seeing. Maybe it's a little less than. There's definitely a lot of solving problems. There's definitely a lot of knowing how to calculate distance. Javen, good to see you here. There's definitely a lot of knowing how to calculate distances. And don't worry, I'm not getting rich off YouTube. If you do the math on it, this semester alone, I made $75. So, or this, we could do the whole year. It's just, I don't want anyone to be like, Brown's getting rich off YouTube. This year, I've made $364 on YouTube, and the year's almost over. So, I always like to do Kahoots. This is how we get a little bit of the money for Kahoots. So you can actually, it's cool. You can actually click the revenue. Woo! It's fun when you make like a big day is like, I made $14 today. That's a huge day. That's $14. You can make $14 every day. That'd be amazing. Yeah, exactly. That's how I finance. I don't want to, the reason I monetize is you get more views. Like our views actually went up when you monetize. And that way, a lot of the general purpose videos, not class videos, have ads on them. But you can actually go over here to the content and monetize stuff, but I don't monetize the class. It is possible though, and it'd be possible if I wasn't monetized, that if I play something like, if I play this too long, we actually get hit with monetized, because Monster Cat hit us with monetization. And thank you to the plus 932 new subscribers. We're almost at 5,000, and we've got 250,000 views this year. So if we had gotten 250,000 views every year, we'd be doing better. It'd be interesting to see. We monetized. Like, how did we do in 2018? At this point in 2018, which was before we were monetized, so we had 250,000 right there. 2018, we weren't monetized back then. We had about half, not even half the views. And then if you go back further to further times, like 2015, we've definitely been growing and doing better. But we also live stream now. We've gotten 50,000. So it's getting, we're doing better and better and better. It's just crazy to think. It's really fun to see like my first live streams. I think was the first live stream a Kahoot. Let me look at that and then one with that. Content. You can actually go to live. And so we're currently live right here. And then you can go to like the oldest. So it's pretty fun. It's like a walk down memory lane. So the oldest there was right there. Stat Tool 1 review session 2015 right there. There's a Kahoot. This might have been wait, here's the first Kahoot. And I am on the phone talking with my wife. So at the very start, she wasn't my wife then. Okay. There I am right there. I'm like, is it live? I'm like, there's me.
It says I'm live. Can everyone hear me and see me now? Let's see, You see me now? All right. I have confirmation from one individual. Can you guys hear me? There is a lag. So if you're in the chat right now, so we're gonna do a test. I'm communicating with someone on the phone right now, and they're helping me out. Anyone in the chat right now? So we're gonna do it. So funny. When you see me, I'm watching it live too now. When you see me snap my fingers, tell me when you see me snap them, okay? Here, they're already joining the Kahoot. All right, looks like a 5-second delay. So There we go. I see some people. Well, I think we got this figured out. I'm gonna start. I don't know if you want to watch. Yeah, feel free to watch or play along. It's like we got a 5-second delay. Okay. Well, thank you very much for your help. Are you gonna watch or play along? Okay. Well, tell me what you think of the review. Bye.
Aw.
Hey everyone. Okay, so
Hey everyone.
looks like we got people joining
Still
in.
saying that. Hey everyone.
You can see the instructions. I'm watching it with you guys too right now. There's a little bit
I have
of
no idea what the
delay.
names are going to be. That's before I gotta watch out because this was before I stopped the allowing of random names. Oh yeah, no, she's always helped me out. She was actually the reason she suggested we do Kahoots. She was like, Kahoots are fun. They're so cool. She's like, you should do Kahoots with your students. And I was like, yeah, it's cool. And so she's the reason we did Kahoots, and this got tons of views, and people learned and had a great time. 1.7 thousand views, 1.700 views, 100 views. So yeah, it says 4 years ago. No, it said 2015 in it. When did it say 2015? It's 2015. Oh no, it's 2018. Okay, that's not as long ago as I thought. This, I'll show you one last thing right here. If I'm correct, this one, yeah, it is. There it is. Look where this takes place. Look at this one. Stat overload here. It's gonna I think YouTube like downgraded. Look at this. There. Wow. Oh, that's type 1, type 2 error right there. 1, 2, AB. Gonna teach some type 1, type 2 error. Look at the lag on that. This is some high quality streaming right here. Trying to figure out like, wait, is that working? Wait, can't see. What's going on? Oh my gosh. This is why people delete their old videos. I know G+, Google+ doesn't even exist anymore. I'm like, okay, is it working? When am I going to start? I was like, I don't know. Gonna do some work after this, but and this is the best video ever right here. Oh wait, here we go. How's that audio? Wow, look at this. Oh, my Batman watch. Brian, what's wrong? Why you spend 3 minutes looking at the internet screen? Wow, reviewing my old videos here live. Here we go. Hop forward. Yeah, I mean, I look so unhappy right there.
Switch over and hopefully it doesn't get angry at me sharing so much. With the Word document, we have written on here.
Oh, thank you.
The null is that the drug is unsafe.
Try.
The alternative is that the drug is safe. Now, with this in mind right here, just think about it.
Just think about it.
Type 1 error is a false positive. A false positive means you have evidence when you
This
don't
video
actually have
got a couple
evidence
hundred
of what?
views, which is awesome. So people have always been so positive in what we've been doing, like with their support and as we've grown. So I try to tell people who do education online, I say, I've been doing this for a long time. This video came out in 2015. So yeah, this is, there's my one view on it. Look at that. Engagement. Concurrent viewers. I had 7 people watching live. 7 people. We got 7 people? What? No way. And then more people watched it afterwards. Yeah. So I shouldn't worry. I always try to remember if people are, they might watch it later. So I try to remember that. And look, there was a spike right there. Whatever happened during that, but all the way back here in 2015, and it got a couple hundred views soon after, and it was used a lot. Used for 250 hours of studying. So that's really great. And that's what matters to me is that, so sometimes when I'm doing an example and people don't answer, like this is the psychology in my mind, I'm like, people in the future might hear the answer. I always want people engaging with what we do, but then I try to remember I'm not just doing the video for people to watch live. It can be for people later. So I'm always thinking like, okay, how does this help the person who's watching it later on? When I'm teaching in person, we answer every question. I'm like, we're answering these questions. But you have to think about with your online teaching, like if you're doing a recording and you have a 5-minute pause, no learning's being accomplished, and then no one's going to watch the recording. So I don't know. It's a lot of fun, a lot of great stuff. With that in other classes too. Well, thank you so much. That's what we try to do right here. So I'm always watching the analytics, and it's really cool. Like if you go to like our classes and stuff, you can actually look at the analytics from a class we have and see how things are doing, what percent of people are watching, engaged. And so I'm always trying to up it. And you see all of the monetization on these are off. Like anything we do for class, it's all like I don't monetize like every video. It's just ones like I try to make for general purpose that I want to reach a wider audience. So almost all the videos are off. Oh, and then we got some test streams right here. This is cool. This is the first attempt at streaming online.
Okay.
This is our first attempts. Oh, I missed that shirt. That's
You
a.
should see me go live here in a moment. There'll be quite a bit of a delay. You're probably going to see this.
Go back into the live control
and
room.
we can do
Oh, was it me?
some stats start here in the lower third.
There we go. This is one of our first attempts at going live. Had more space to walk around. Yeah, so this is a unlisted video right here. So just testing.
Got some fun videos and stuff that would not normally be right there on top of that.
It's all the memory lane. And so this is 3 years ago of learning how to use Stream Decks, and just back in the day right there. Back in the day. Got more lighting, got more everything, got the Huion right here, the Huion tablets right in front of me right there. And that's when I was using a boom mic. So the boom mic was being used. I don't know. Brian's just going down memory lane right here. I think I still have that background. With that, and I've got a new thing. I got a new idea. More ideas to come. Thank you, everybody, as Brian walks down memory lane. Let's play one of our cool outros. Let's do a cool outro to end. We're going to do one of our favorite outros. So here's one of our favorite. If you stay till the end, you get a favorite outro. Here we go. Favorite outro to end class. Let's do it.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Bye, everyone.